So good afternoon, everyone. I hope you have a great start of your week. Today's what? Yeah. And then everything's fine with you. Okay, so does anybody have any question before I keep going? I just put my tags up so I can see what's going on. Anybody have any question before I keep going? Okay, no questions. I know some of you are asking me about whether we can use online calculator. I'm gonna see if I can do something right now, probably because the one that you have I think we have one on Pearson. So I'm gonna to see if I can, I'm gonna work with one of the people soon. Probably we can try to see if we can use start crunch on the exam. I'm trying to see that, okay? If not, that's no guarantee. Because I don't like using website, outside website for when you guys are taking an exam. I like to use the stuff outside, but I'm gonna work on that. You know, so most of the exams, they are based on that the TR calculator, TR83 or TR84 calculator. I mean, whenever you look at the reviews, the person is using the TR84 or TR83 calculator for it to work on. But you also can do the same thing using StatCrunch. I think because some of you don't have that what do you call it, that expensive calculator. And if you are teaching in a classroom, then I would teach you how to use the other type of calculators to do the same work, but it might take a bit longer, but that could be about, I mean, you'll be able to do the job, you understand, have everything done. But this is why now it's like using Zoom, it's hard for me to show you in your specific calculator, and the one that you have in your hand. Okay, so what I'm gonna be doing probably after class today, I'll be meeting one of the people from Pearson. Not people from Pearson, people from oh no, look, to see if we can add it up to your exam. That way it's gonna be easier for you. Okay, so let me start working with you right now. Let me see if I'm sharing everything. So I'm sharing this chapter. I'm not sharing the exact thing I want to see. So let me share it again. Now we see what I'm seeing. Okay. Now, we're going to be talking about something called probability distribution. Okay. And also, after talking about probability distribution, we'll be talking about something called normal distribution. Well, you spoke about the normal distribution before, whenever we used to do the bear shape. And that bear shape is called normal distribution. We'll be talking about them again. And then for that kind of distribution, so we talk about a probability model. It can be something that's something that can be uniform, linear, normal, and other. We already spoke about linear before. Whenever we're doing the shape, with whenever you have the plot, and then we do the straight line, stuff like that. That's why we're talking about linear. Okay, we did that one before. Probably you can remember it. We didn't really speak about uniform, but I could quickly talk about it today. And then the normal, we spoke about normal before. Whenever you have that bear shape, something like that for the bear shape. And then for linear, this is when you have that straight line and all the dots around, something like that. And then that way you can say whether the graph is increasing or decreasing. Is it, and then we talk about what you call the correlation, whether it's a positive correlation or negative correlation. Okay. So get my pen back. Then probability distribution, we also call probability function. It's a table graph or formula that gives all the outcomes from an experiment and the probabilities. In fact, we did speak about probability distribution before. Whenever you use the table, a table with a table like this, in which you have X. Hold on, somebody's coming. Okay. Whenever you have X, and then we have the frequency, something like that. Okay. So let me just give you a quick example. Suppose I say 1, and then this is 0.25. I'm sorry, not 0.25. I think about, let's talk about something called relative frequency. We talked about relative frequency before. Okay, so let's put that be 1.25, something like that. And then you put 2, that'll be 0.50, for example. And then 3, that'll be 0.25 again. So I put relative frequency. We did talk about relative frequency before. If you don't remember, just go back to the previous notes that we did. This is when we add, if I can remember quickly, whenever you have X, something like that, and then F, okay, and then suppose this is that any number, it's also a different example. Then you have this number there, like 5, 10, something like that. And then let's put 6, for example. Then you add, if you add these numbers, that's gonna give you, for example, let me do one that will match instead. So let's stop doing this example. We match the 25 and then 50. Let's put this something like that. And then this is, for example, let's put this is 100. Okay. And this is 25. That's been the number 1 appear 25 times. Number 2 appear 50 times. And then number 3 appear 25 times as well, something like that. Then the relative frequency is something like this. To get the relative frequency, you're gonna do 25 divided by 100. Okay, I'll just use an easy example, but you just have to go and look at what we did in relative frequency. That'll give you 0.25, etc. So you divide the frequency divided by the total frequency. That's what's gonna give you the relative frequency. Now, from the relative frequency, this is when we talk about probability distribution. If I do something like this, and I put P of X, and I put P of X with probability of X, that means that'll be 0.25, 0.50, and then 0.25 again. That means probability when X is equal to 1, that's going to be 0.25. That's what I mean. That's why we're talking about. That's all. So probability for X equal to 1 is 0.25 or 25%. Probability for X equal to 2 will be 50%. I'll give up a better example soon. Okay. Anybody have any question? This is called probability distribution, or I can say probability distribution function, because we use P of. That's why I call probability function. So this is relative frequency. That's why I did in the past. Then just put the term for you so you can look at it for the previous note. Frequency. And this one is called probability function or probability distribution. Distribution, okay? Or we can say probability distribution, or I can say probability function. Okay, so that's the term right here. Okay, so now probably in the past we talk about something called discrete and continuous. So we say a random variable is called discrete if the outcome are value that can be list or counted. If whenever we can count something, it's called discrete. Okay, if you cannot count it, then it can be something else, like number of people in a class or number of classes you take in, that they're called discrete number. Okay, the roll of a die is discrete. Okay, so if it's continuous, you cannot count it. Okay, you can put it you can put it in a range, stuff like that, but you cannot count it. All right, for example, time to finish an exam, you're gonna count the time to finish an exam. You cannot count your height. I can say this is 1 height, 2 height. You cannot count it. You can say you cannot count it. You can measure it. That's a number you can count. You cannot see the letter weight. You cannot see the letter weight until this is count. So discrete is something that is distant, that you can see, like number of chairs in the classroom, number of people in a classroom, number of classes you're going to be taking. These are called discrete. And continuous is the one that you cannot count. Okay. And then this one, you say, this is an example, you say classify whether this is continuous and or discrete. So if we say the length of the left thumb, so do you think this one will be discrete or continuous? So what do you guys think? This is you cannot measure the length of your thumb. Okay, that's a quick thing. So is it discrete or continuous? Your participation is very encouraged. The length of your left thumb, is it discrete or continuous? You cannot count your thumb, you cannot count the length of your thumb. So it has to be continuous. Thank you. Because you can just measure the length of your thumb, but you cannot count it. Okay, thank you very much for your participation. For example, here, this one's a number of children in a family. So if a number of children in a family, is it continuous or discrete? That's discrete because you can count them. You can say one child, two child, etc. Okay, that's discrete. Number of devices in the house that connect to the internet, is it discrete or continuous? Okay, that's discrete also. Thank you. And then sodium concentration in the bloodstream. I'm sorry, in the bloodstream. Sodium concentration in the bloodstream, is it can be discrete or continuous? Continuous, because you cannot count it. Thank you very much. So we did, in the past, we did do some discrete probability distribution. Whenever we were doing, like the example earlier, how many times you see number one, how many times you see number two, we're doing like discrete numbers, okay? So, so we use a table for that. That was very easy. We did it before. He has two columns. One is for the X, the other one is for P of X. That's what we're gonna do. Before, the P of X used to be the relative frequency, but in this case, it's gonna be P of X. Instead of putting the relative frequency all the time, you're gonna say P of X, okay? So this is like a little bit different, okay? So you got two columns, one is X, the other one is P of X, okay? So example, this is an example here in which you have whenever you roll a die, to get a 1 is 1/6, to get a 2 is 1/6, etc. Okay, and then if you add all of these numbers here, that need to give you 1 or 100%. Okay, so another example, waffle size price for X is, whenever it's 95 is 0.01, for 9995 it's gonna be, for 995 is 0.005, for -5 that will print something, and then if you add all of them, that should give you 1. It has to be 1 or close to 1. Okay. Okay, that's gonna give you 1. If I put to this one, that's gonna give you 1. So the acceptable numbers are something like this. Can be either close to I know he's gonna say it must equal to 1, but acceptable are something like this. Can be something like this. Can be like 0.99. Let's put 7 is acceptable, and also anything close to this one is something close to 1.001, for example, is acceptable. Okay, let's just put 999. Let's just put 999 right here instead. Okay, these are acceptable number. If it's something close to this one, then it's fine. Okay, this is a reasonable. It's very reasonable to go that far. Okay, or to that low. So whenever we do the probability distribution, we used to do something called a bar graph. Okay, Right now, I'm just going to show you, you don't have to specifically to use a bar graph all the time. Okay, we can use anything that we want, but the example I can just show you here is something like this. Okay, here when P of X is equal to 0, you got 0.4. So if I say P of X is equal to 0, I'm sorry, I forgot to close the parentheses. P of X equal to 0, then the answer should be 0.4. Okay, and then P of X is equal to 1, your answer should be, that's a 1, not a 2, then the answer should be 0.6. Okay, that's, you just use that. I can use anything I want. It doesn't have to be like a specific, nicely done bar graph. Okay, and then another example, I'm an ambassador rating. For 1 star, you have 0.3%, 3%, I mean 30% for 1 star, and then some numbers between 0.1 and 15% for 2 stars, and then etc. Okay, so these are examples of a distribution graph. Okay, probability distribution. So you can also do a bar graph. Here I just do a line, so that's just kind of the same thing as the bar graph. Okay, that the thing is that whenever you have to do probability distribution, there's a special formula that we use. Unfortunately, you're not going to be using in this class, but it's good to know, to see about it. This is a formula that we use to calculate a probability distribution. Okay, this is mainly related to something called binomial distribution, but I don't think I'm going to be teaching, but it's going to be based on binomial distribution. But if you use the calculator, then it should be fine. And then this formula that will help us to find probability distribution. That's a formula we can use. But let's quickly talk about something else here. What this is whenever you have a discrete probability distribution, if it's discrete, okay? But if it's not discrete, you're gonna have to use that kind of a graph. Remember the bear-shaped thing? But something like this, okay? But before we talk about it, but just an idea here, just to understand. Here they give you a graph. They say X is between 0 and 1 to find the probability of waiting time between 0 minute and 2 minutes. Okay. So here, the value of X is right here. Is either between 2 and 0. That's the value for X. You want to know what will be the probability between 0 and 2. So that shaded region that you see here is the probability for that. You don't know how much is it in this one because then I didn't get any value here, but it gives you an idea. Okay. And then if you put everything, if I say, for example, I say find the probability from 0 and then goes to less than X, less than 5, the entire thing must give me 1. Okay, or something close to 1. Or something like this, or 0.10101. Okay, acceptable. So that's why it is. Okay, so probably you got something here, X and B between 0 and 0 and 2, and then etc. Okay, so we do represent a curve. Okay, it's the area of the curve between two values of X, and the probability of X being the between the two values. Okay, and also the total area under the curve must equal to 1. Okay, so if you add all of them, you need to give you 1. Let me quickly, yeah, this is for the same rating. Let me quickly show you what I'm talking about here with the rating. Let me just show it to you quickly. Let me go back. I'm right here. So if we look at the graph here, suppose this is 0.15 right here. 0.15. This one is 0.18. This one here, probably 0.19, 0.18. I'm assuming sorry, this one will basically be like 0.19, something like that. Let's see. And it's gonna be 0.20. So what is the probability to have a rate between, that's an example, okay? A rate between, let's say between 3 and 5. Okay, something like that. So what I'll do, I add the rates. I would say it's going to be 0.18 plus 0.19 plus 0.20, something like that. Okay, so that's what I want to try to explain to you. But at the end, if you add all of them, if it's a probability between 1 all the way to 5, this one will be something close to 1, okay, or 0.99, something like that. That's what I'm trying to explain to you, okay? Give me a moment, let me just go down. Okay, that's what I'm trying to explain to you in that idea right there, okay? It's now because we're dealing with continuous data, we cannot count it. That's why I didn't do the bar graph. Here it's just like having like individual bar graph, like micro bar graph, okay? Because this is continuous, I need to show a curve instead of a bar, okay? I have to show a curve instead of a bar. We do have another example of whenever something continues as well. Let me just talk about quickly the probability of uniform distribution. I just talked earlier about it. So here, we want to find, this one said the curve above show the probability distribution function for time to wait for a bus that come every 12 minutes, okay? It come every 12 minutes. Okay, they say find the probability that you will wait between 5 minutes and between 5 minutes and 10 minutes. So I got the probability between 5 minutes and 10 minutes. So what I'll do, this is uniform because what happened, there's a straight line. If you have a straight line like this, like a little box, this is called uniform distribution. You have to have a little box. So I don't want to mess up the shape. So what I do, I look at between 5 and 10. Okay. So here, for between 5 and 10, you got this is going to be your shape right here. Okay. So let's do the graph here. Nope. Yeah. Okay, right here, between 5 and 10. All right. Again, this is statistic is not really exact science, just totally, but I know in the past I didn't really do that. But if you do something called like whenever you have something like this, if you have a rectangle, okay, this is if they have to find the area of the rectangle. That's the term I'm going to be using also in the future, the term area or probability. I'm going to use the same term. Usually, probability area will be length times width. Okay, length times width. Okay, here. Okay, we can. Some people like to put the width on top, so I can change it for you. So just avoid any confusion. So I can just do this. This is the length. This is the width. Okay. Notice that from here to there, from 5 to that can be 5. So that's going to be that the length is 5 times. Now the height or the width is that length right here, which is 0.088 something. That'll be 0.0833 something. Okay, you do length times the width. Okay, because the width is 0.08 something. Then whenever you do that, you're gonna find the area. That's a term I'm gonna be using in the future. I'll be saying area of area. I will use the term area of probability. Okay, so So finding the area of the rectangle, you're gonna say the base and height. Some people say length and width. So between 5 and 10, that'll be 5, and that'll give you the value. That's mean the probability that you're gonna be waiting between 5 minutes and 10 minutes will be 41%, or 0.41655. Okay. Any questions? Any questions? Okay, so if no questions, so this is what we're gonna be doing. Here again, I was telling you that before, whenever you got that bell shape, it's like, yeah, it's like a bunch of micro size bar graph. You put them together because this is continuous. Then we put them together to give you that bell shape. Again, I remember the past I told you that for us to consider this class, whenever you do the graphing, it has to be a bell shape. If you don't have that bell shape, it's going to be hard to continue the class. So you have to use another type of statistics, which is called non-parametric statistics. Because using parametric statistics, we want to have that bell shape. That's very important. No bell shape, then it's going to be hard. Here we have that model. You wanted in this case, whenever you have that bell shape, it's going to call a normal model or normal probability distribution. Normal probabilities, okay? So it has to be unimodal. That means it has one mode or one peak. Okay, I think we talked about it before. It has to be one mode or one peak. Okay, it's symmetric. That means everything on each side is the same. You will scoop it on each side. Okay, you have a bell shape. That bell shape is very symmetric on each side. That means here is in the middle. Apparently right here at the center right here, everything repeat itself. Okay, everything repeat itself at the center. The left side is repeating the other side. It's like walking itself in the mirror. Okay, right here. Here is like a mirror. That's why I say it's symmetric. The on one side repeat the other side. Okay. And then the normal distribution is also called Gaussian. If you want to use that nasty term, Gaussian, go ahead and use it. Okay, but I would say in the future, normal probability distribution. And one thing we need to understand about this thing is that if you have the smaller distance, if you have really small standard deviation, then the shape will squeeze in. If the standard deviation are very large, the shape of the distribution will be wider. I think that was one of your questions in the last exam. Whenever the standard deviation is big, what it is. If it's small, and what it is. If it's small, it's going to be very close to the center. If it's big, standard deviation, it's going to be very large. Okay, very open. That was something we spoke in the past about. Now, let me introduce you to this thing. We need something called the mean. Okay, the mean mu. Remember that term I also spoke to you about it way back in the days. I mean, whenever I start this class, that's the expression mu is also the mean. You use that mean for population. Okay, this is the mean. Okay, we also use for standard deviation. Okay. We also talk about this guy, the sigma standard deviation. The way you pronounce the one over here, you pronounce it as mu. This one is pronounced as sigma. I know if you remember that. You guys, I'm pretty sure you guys remember when this the symbol when you spoke about them in the past, back in the days, at the beginning of school, a class before the first exam. I did say that the X bar is the mean for a sample, something like that. And then the S, we can say, some people like to put like this. You're going to put in parentheses, this is X bar. And then you use that little thing. But I say you need these two things for a sample. Now for population, we have the mu and then sigma. And you can say mu, sigma. Okay, the idea is like X bar is trying to express mu to the best of his knowledge. And so S is trying to express sigma to the best of his knowledge, okay? For example, I am from the island, okay? Suppose I'm a mean person. And then you meet another person that come from the same island who is a mean person. If that means somebody that come from my country is mean. Finally, your conclusion will be everybody from this island are very mean or is very mean. Everybody that comes from there is very mean. So you don't have to travel to that specific island and ask every single person of them to find out that they're mean. But based on the people that you interact with, you got an idea of the entire population. That's why the X bar stands for. That's why I think I spent to at the beginning of class. The X bar trying to explain the mean, the S one to represent in the standardization. Okay. So also, if you have to do the mean mu, you have to do something called you have to go and ask every single person, which is going to be a hard work for you to do. And then this is called a census. We don't have enough a resource to do a census, but the state can do it. The government can do the census, ask every single person. But if you have to make a study, you're probably going to find a sample, study the sample, then get an idea about the entire population. Okay, so that's why it's just a quick reminder. So descending, just how I was saying to you earlier, the Greek letter mu and sigma are used for distribution, and X bar and S are used for sample. Okay, so just how I see this term sample right here. Okay, this is a little bit confusing when they say distribution. This is not correct terms, but you just say population. Okay, and then X bar and S are used for sample. The other one will be population data. Okay. Any questions so far? No question. So this what happened. Now this is when I'm going to need you to learn how to use StatCrunch. I'm going to show you how to use StatCrunch. Here we have a bar graph. I mean, not a bar graph. We have a number distribution. Okay. Here the mean is 6. Right here. It's at the center. Where's my cursor? Sorry. The mean is 6. Okay, let's do that. This is the mean right here, which is mu. Okay, the mean is always at the center. The standard deviation is 2. This is the mean mu, and the standard deviation is 2. Why do you know the standard deviation is 2? Look at this. Between each number, this is 2 right here. The distance between each number is 2. This is twice 2. This is 3 times 2. Okay, that's when you do 6 plus 2 will give you 8, the next number. If you do 6 plus 2 times 2, that's going to give you 10. If you do 6 plus 3 times 2, that's going to give you 12, etc. We talked about that before. Whenever you see that symbol, which is going to be X bar plus or minus, and then the Z score times the S. I don't know if you remember this later then, but I'm going to use the symbol and this symbol instead, which is going to be mu plus or minus the Z times sigma. Sigma is the standard deviation. So this is a new way right now for population. This is sample. In this example, we see a number 4 right here. This is called X. So this is the question we're going to ask ourselves. As you can see, there's a bunch of things below X. I will not put P of X is equal to 4 here because this is continuous, okay? I cannot use that. Because the graph is on the left side of 4, I will say find P of X less than 4. I can say less or equal than 4 too. That's the same thing. Okay. This will give you the graph that is on the left side of F. Or I can say, if you wanted to go on the right side of F, you're going to say P of X greater than 4. Okay. So without wasting too much of your time, let me go to start crunch and show you how to work it out. So first, let me finish that one first and show you what we do. So let's talk about it first. Let's say you're going to say, I'm sorry. You're going to say, where am I? Okay. So the area under the numeric curve above the x-axis and to the left x-axis equal to 4%, P of X equal to P of X less than 4. That's what I said earlier. And then you can say P of X less than 4 or P of X equal to less than or equal to 4 is the same thing because they are continuous. Okay. So let's go together. Let's go to, let me just stop sharing this one. I'm going to go to start crunch. That you have. This is the one I'm going to be trying to see if I can put it in your exam for you, just in case you don't have the scientific calculator, but you don't have, you can use your own thing too. Okay. So let me just share, stop sharing that. Let me just share. Let's go to online right here. Okay, let me just show how to get the online one. So if you go to your class and then go to unlock. No, sorry, not unlock. You go to Master Lab right here. Okay. You guys following me? Then if you click on open my start lab master, you will do that thing. Then it's gonna bring you to let me just erase that. It's gonna bring you to your class, to right here. This is your class. This is how I'm gonna show up for you. Okay. Then you're gonna click on start crunch right here. Click on start crunch. You got following, right? The instance you can say start crunch website. Are you guys following me? Can you guys see what I'm doing?
Yes.
Then when we go to start crunch websites right here, this is where you have it. Now you're gonna click open start crunch. This is where you're gonna have them. Now, earlier today, I'm gonna share my entire screen instead, if I can do so now. So I can just pull up the Excel sheet. No, that's fine. So I'm gonna go show you anyway. So earlier today, we talked about something called, let's go. If you go to start right here, you go to start, you go to calculator, you go all the way down to normal because you do study normal right now. You go normal, and then this show up for you. Can you see the little graph that show up? Yes or no? So I can just see on our screen instead.
Yes.
You see that little graph? I'm shaking. Do you see? I'm shaking it right now, right? Can you see it?
Yes.
Okay. Now here they ask you to put the mean. And the example I was doing earlier, the mean was 6. Okay. The mean was 6, and the standard deviation was 2. That's 2. And then the probability they were looking for was 4. Okay. And then again, as I told you earlier, either put less than equal to or greater than the same thing. You either put less than or less than equal is the same thing. I'm going to put less than equal to, and I would compute. Look what happened here. You see, this graph is exactly the one that we're doing earlier. If I want to find the value, I would say it's going to be 0.15 something. Okay. So I'm going to show you the graph right now. Stop sharing that and share my screen right here. As you can see, this one looks exactly the same thing that we're doing earlier. But in that case, let me try to get my pen. In that case, this value here for the graph, that will be P of X less than 4. I can say if you want to less or equal to 4, that will be 0.1586, 1587, something like that, if I round it. Okay. Or I can say this is what I mean. It's about, you can say about, if you want to interpret it, do interpretation, you can say about 16%, if I round it, of the data are below 4. Okay, so 16% of the data are below 4. You can say 15-something% of the data are below 4. And that's how you use it. Okay, what did I just do right now? Let me see. What am I sharing again? I'm showing the PowerPoint. Yeah, perfect. So what am I doing now? If I go quickly, if you notice over there, well, my cursor, I lost my pen, cursor again. So here, this is what we just did. To do it, we just went to, we go to start, calculator, normal, and then this is later, I'm gonna let you just go and read, okay? So I don't have to go about it, okay? So that's what we just did, okay? So you can use that to help you out. You guys see that? What we just did. Now, we're gonna use this using start to do some other problems. Here, I mean, this is what we just did. You go to normal, and then again. And then we did the same thing right here, and then to compute. That's what we just did. Very simple. Okay. Let's do another example here. This one say, research has shown that the mean length of a newborn Pacific arbor seal is 29.5 inches. Okay. So here I already got the mean. I'm going to say mu is equal to 29.5. Now the standard deviation is 1.2. Some people like to put it like that. They put parentheses about 29.5, like this, and then comma, and you put 1.2. Okay, that's a star. If you, I mean, we use it all the time. Okay, you can use it too, and then that's the one. Now they say that they want to know the probability that a randomly selected pop will be more than. This one say more than. More than means greater than. That means X must be greater than 32. Let's do that together. I'm gonna start sharing my start crunch. Let's go to share. Where is my start crunch? Right here. I'm just sharing on entire screen instead. Right here. So here. So again, the mean is 29.5. 29.5. The standard deviation is 1.2. And then they say greater than 32. I put 32 right here, but remember, this one says less than. So I'm gonna change it to greater than. You put either put greater than equal to, or you can put less or equal to. Doesn't matter. Then you put compute. And this is what we have. You just delete it, and that's greater than 32 is about 0.2%. Okay? I'm sorry, it's about 2%. Will be more than 32 inches. Okay? So now let's go back to the note, to the same thing we just did. Right here, let's go start sharing. Let's go to the notes right here. This is where we are. Okay, so we do that. Oopsie. I wrote on top of it. So this is what we have here. Can you guys see it? I think I put some notes on top of what I'm supposed to be writing. So, and then that'll be about 0.019 something, okay? All right, that'll be your answer. Let me just erase that whenever I print the note so it doesn't mess you up, because I already know what I mean by that right here. Okay, so if you want to do some conclusions, you can say about 2% of the kiddos of them will be or will have their length more than 32 inches. Okay, about 2% of them, if you want to round it. Okay, that's the interpretation of it. Are we good? Okay, is there any homework that correlates with what we are learning? I feel like the person homework. Again, the person homework, as I told you, this is a third party. So what I want you to is to use your notes, the one that I'm gonna give it to you, and also use the review for the exam. That's why I said at the beginning of class, not everything in Pearson will correlate with what we have. You have to use your notes because the exam is based on the notes and the review. Did I answer a question? Did I answer a question? Bista, did I answer a question? Use my notes. I'm gonna give you the notes. You're gonna get some examples on it that you're gonna go and practice. And also use the notes and use the review to get ready for the exam. The exam are prepared by your mathematics department. Okay. And then Pearson is a third party. They can give you whatever they want. And then I'm pretty sure because you guys are very rich people, they want you to just buy it and just make them decide. Okay. So we're so rich, then we have enough money so we can just buy extra things even though we don't really need them that much. Anyway, but the good thing about it, whenever you use Pearson, we have the start crunch. You probably can use. I'm gonna try to. I can put start crunch for you to do whenever you're taking the exam. So you can go to that website and then do the exam. Okay, I'm gonna do that after class today. Okay. The exam is not on paper. The exam will be just the same thing as the previous one. It's gonna be using Honor. Okay. So you're gonna be using Honor for the exam, and I'm gonna later on, I'm gonna try if I can add it for you. So I do have more example available for you that you can go and practice. But I'm gonna do one last example, and I'm gonna put up the notes for you to just go and practice the same thing I just did. Okay. Let me see if I have to put something here. You can just go and practice the idea behind that. Let me see. We did some of them already. So let me just put, let me see. Yeah, so, yeah, let me do a couple more example. Yeah, I'm gonna put the notes for you later on tonight so you can do the practice. But I have to do a couple example with you first, okay? Let's go back to the notes. Okay, let me just stop sharing that. Share my notes. And then let's go back to the, nope. Right here. So, and then right here. Now, if you want to find the probability between two values, for example, they say find the probability between 3 and 6. So how do we do that? We're gonna use search console to do the same thing. Okay, either you do them separately, just using StatCrunch and to get the answer, but we also can do it together in StatCrunch. I'm gonna show you how to do it right now. Okay, so let's go back to StatCrunch. This is one way. You do this one first, then you got this one for a second, using StatCrunch, one by one at the same time, then you're gonna get your answer. Okay, between two values. Okay, in this case, they give you the mean. The mean is 4. Can you see my notes, guys? The mean is 4, and the standard deviation in this case is 1. Okay, can you guys see what I'm working on? Because I'm using too many screens, I just want to make sure that I don't get anybody lost. Can you guys see what I'm doing now? Be patient right now. This one has a finding the probability between two values. Can you see it?
Yes.
So we're gonna do that in StatCrunch together. So let me just stop sharing that. I'm gonna start sending StatCrunch. So how do you do it between two? Going back, the mean is 4, so the deviation is 1, and then we need to find the value between 3 and 4. If you do it using the method we're doing earlier, you're gonna find P of x less than 6, P of x less than 3, then you subtract them, that'll give you the answer. But we also can do them in one shot using StatCrunch. in a different way. So let me share my screen with you. New share, and then let's go to screen 2. No. I need to share SoundCloud. Yeah. Here we go. So again, this is what we're doing. You can go here, as you can see here, this one stays standard right here. If you click between, that is what we're gonna do. If you click on between, then you're gonna put the answer here. The mean is 4. Standard deviation is 1. And the value is gonna be between 4 and 6. Right? No, between 3 and 6. 3 and 6. You say compute. As you can see, you got the same answer. All right. So this saves you time. Okay. So you get the exact same answer. So whenever I say between, just come and do it right here. All right. Now, I do have a few examples I want to show you again. So let me just stop sharing that right now. Let's go to start sharing and go back to my notes. We'll go right here. You guys understand the answer? Using Scratch Punch? Do you guys understand that? Yes, no? Okay. This is what I'm gonna be doing. I know I don't really put my videos on for you. I'm gonna make this video available for you just in case you need some extra help using Start Punch, because the example that we have is using, I mean the one we have for the notes for the exam. I'm talking about the one that we have for as a review for the test is using the TR-84. But you see, you can use this one too if you want to. But I'm going to see if I can add this Saturn. Give me until tonight, and I'm going to confirm with you later on today, okay? So now, where am I? Now I want to know which screen I'm sharing. Okay, I'm going to share my flower site again. Okay, now let's do a couple more examples. Now this one here, they give you this one, this is what they ask you to do in this example. They give you what happened? They give you this number. They say P of X less than question mark. And then this is equal to 0.10. So what's question mark? Okay. I know this is what you do right here, but this is what you do in Start Punch. I'm going to show you, go back to Start Punch. We're going to do it together. So how do you get question mark? So let's go back to Start Punch. Again, here, you can see that the mean is 29.5 and the standard deviation is 1.2. Let's go back here. The mean is 29.5. Standard deviation is 1.2. Okay. I'm sorry, I need to go to standard. Okay. Now we don't know this guy. And they say he has to be less than. Which is less than. Okay. And then here I'm going to put 0.10, 0.1. Okay. Once I put 0.1, I can compute. Then the number I'm looking for is 27.96. I can just say it's about 28. If you want to want the smart places, if you want to. Okay. So that's how you do it. It's very simple. Whenever I use it, is this one. So let me go back to my screen. Let's go back here. As you can see right here, that's what we're talking about. Is this one give you 27.96, or I can just say 28. Okay. Very simple. So this one say the 10th percentile is about 27.96. So yeah, so like that. Okay. Any question about it? I'm sorry about it. My quota is working now. Any question about it? No question about it. We do have some examples available for you to practice. And then I want to put out something here quickly. Whenever you're using normal distribution, this is what's going to happen. Let me just skip that for now. We like to use something called, no, let me just skip this one. Like, for example, this is the Z-score, okay? This is, I know we talked about something called the Z-score before. Okay, so this is fine. We talked about it before, so I'm gonna skip that one. So you just have to review this one. This is a review. Okay, sometimes you can do the study, you're just using the Z-score only. In that case, suppose you have a mean as 500. This is the mean, and this is standard deviation as 100. Okay, so you can convert this one into another thing. You can convert this one into something like, in that case, the mean becomes 0. The standard deviation is always 1. How do we do that? It's because the location of the mean to itself is always going to be 0. Suppose I find z of 500 minus 500 divided by 100. That means z is equal to 0. The location of the mean to itself is 0. How far the mean is from it to itself is always going to be 0. So I can switch it and put something like this. And in that case, I'm going to have the mean as 0 all the time, and the standard deviation will be 1. I can do that too. Now, this is the case here. We can always use, usually start ones can become easier. This one say, refer the numerical curve, explain why is the right below the z-score of 0. We just talk about it, okay? The location of the name is 0 at the same time. Let's see. So here, what we do, if you do for each, for each of the single values, like 670, something like 800, you're gonna give you the same idea, okay? I think we talked about that before, but this is like a review. I just wanted you guys can go and read about it whenever I spoke about it. Okay, it's the z-score, whenever you use the z-score. But this is what I want to talk about quickly right here. So here, they give it a z-score as 1.75. And they don't give it, I know we know the value is 1.675, okay? They give you the value as 175. Okay, they wanted to find it using they use SATCOMS to find it. Whenever they say z-score, that's the key to term. Whenever they say z-score, know that the mean in that case is going to be always 0. The standard deviation is always 1. That's what I wanted to remember. Whenever you say using the z-score to find the area means the same thing as probability. That's what I told you earlier, probability or area. They say to the right, that's mean something like z greater than a, greater 1.75, because it's to the right. The right means greater than, okay? So we need to find p of z greater than that, okay? Again, whenever you see the term z and a parenthesis like that, it means the mean is always 0, the standard deviation is always 1. Did I make myself clear enough? Whenever you use the term z inside the probability, the mean is always 0, the standard deviation is always 1. Did I make myself clear enough? Yes or no? Yes or no?
Yes.
Well, give me a moment. Because some people are not listening. Okay, so whenever you have p of something, it can be the mean always the standard deviation. So let's do StatCrunch to do it. This is how we're going to be doing. Let's share my screen to StatCrunch. So this one say 175, okay? So remember, the first I'm gonna do, I'm gonna put 0 for the mean and 1 for the standard deviation. I'm forgetting about z. I know this one says x. By default, it's a x, but I cannot change it here. But I know the mean is 0, standard deviation is 1, okay? I cannot change the design of that. So here I'm gonna put 1.75. But this, because they say to the right of, I'm gonna say greater than, okay? And I've said compute. As you can see, it gives you 0.0 something, okay? You see that? It give you 0.0 something. That's mean on the side, on top of that, it's going to be 0.0 something. Okay, so I'm going to go back to our notes. Let's go back to our notes right here and share. So this is where we are. That's going to be 0.0 something. Okay, we can just say, but this is going to be 0.04. Okay, and if you do the rest of it, that's what we have. Oh man, I went over that thing again. I always forget not to write over that. Okay, so that's why I give 0.04. If you do put something else, the answer will be different. Okay. So you can practice that on your own. This is what we did right here. Okay. So you can say about 4% of the female college-bound high schools are scored above 675. This is the interpretation of it. Okay. Because that 175 will present is the Z-score for 675. I didn't get the 1.75 again. It shall show you. It is Z is equal to 675. You call it 500 divided by 100. That's gonna give you 1.75. Okay, that's the Z-score. This number, it will present 675 in a normal way. This is called normal. Okay, this is normal. Okay, in fact, this is not in terms of normal. This is called standard normal. In fact, that's the term, standard normal. It works for everything. Okay, I'm gonna stop here. What I'm gonna put the note for you to have more example. You can practice on your own. So I'm gonna stop here. And then you guys practice those things. If you have any questions next week, I can go over them. We can do some more examples next week. Okay, on that, on Tuesday, hopefully, but practice them. But if you don't have any question, I will continue the class. But if you have questions, I will just go over some of them with you. Okay. Okay, have a great evening, a great weekend, and I'll see you guys next week. If you have any question, please stay for me to talk to you. I'm gonna stop the recording, and I'm gonna start putting the notes.